I'm deeply honored to be here today as the keynote speaker for the International Conference on Composite Material for Environmental Protection and Remediation 2024. The conference, organized by the Department of Chemistry at GB College, Ramgarh, in collaboration with BKS University, under the flagship of the Chemical Research Society India, Bihar and Jharkhand local chapter, represent a significant gathering of brilliant minds dedicated to advancing environmental protection through innovative composite materials. I would like to extend my heartfelt gratitude to the organizing committee for inviting me to speak at this prestigious event. It's truly a privilege to share my insight and engage with such a distinguished group of researchers and scholars. I look forward to discussion and exchange that will take place over the next 2 days as we explore the latest advancement and collaborative efforts in our field. The topic what we are discussing today, the nanoscale, exploring the synthesis of nanomaterials. These are some of the particles which my team have synthesized recently. So a scale. We can define scale in various ways. A meter scale, a millimeter scale, atomic scale, nanoscale. First, I briefly introduce nanomaterials. Then I give typical some tips how we can synthesize some particular nanomaterials. Nanotechnology. Here in the picture, you can see number of atoms are laying on the surface and a few atoms are displaying on the top. By these top atoms, we can align the bottom layer of the atom. Means nanotechnology is building tiny invisible building blocks by more control. Nanometer, actually, the words came from the Greek nanos, mean the smallest tribe that ever have happened on the this planet. Typically, a nanometer belongs to 10 raised to minus 9. Nanomaterial can be defined in a number of ways. We can have zero dimensional, one dimensional, two dimensional, three dimensional. Whenever we are going to synthesize nanomaterials, we have to take care of these parameters, what we are going to synthesize. In zero dimensional, all the dimension belongs to nanometer. Nanometer by mean 1 to 100 nanometer range. If we have all the dimension 1 to 100 nanometer range, we have zero dimensional, or particular this material is called quantum dot. Synthesizing quantum dot is a very difficult and challenging task. In other way, we have one dimensional material. In one dimensional material, we have two dimension are greater than in nano, and one dimension is only in the nanometer. Similarly, we have three dimensional and four dimensional nanoparticles. Nanotechnology is introduced by one of the earlier scientists, physicist Richard Feynman, in 1959. We have a very here he has a very good lecture on the plenty of room at the bottom. If you are really going to study nanomaterials or nanotechnology, first go through these lectures. In the early notation 20th century, many researchers had explored the meaning of nanotechnology. Nanotechnology is not a new technology, but it's a very early technology. Here are some briefs who are the major contributor in the nanotechnology. Current state and future prospects. Nanotechnology continues going to evolve, focusing on understanding the nanoscale phenomena. Now we have different phenomena in the nanoscale. First of all, we will discuss macroscale. As shown in the figure, we have some microscale which are visible with the naked eyes. In a microscopic scale, not directly visible with the naked eyes, but we can have some microscope to view the things. In atomic scale, similarly with microscope or atomic scale, we can directly see the atoms. And on the nuclear scale, we can have the glimpse of electron, proton, like that. But in between microscale and atomic scale, there is another scale called nanoscale. It comprises of 1 to 100 nanometers. And believe me, we have a very distinguished property in this scale. Suppose you are having meter scale. Meter scale goes 1 to 100 centimeters. We have an object of 1 centimeter and we have an object of 100 centimeters. Both the objects will show the same properties, no matter it is of 1 centimeter, 2 centimeter, or 100 centimeters. In the similarly, if we have a millimeter scale, no matter we have 1 mm size object, 2 mm size, or 100 mm size, all the particles, all the objects will show the same properties. But at nanoscale, in the range of 1 to 100 nanometers, eh, if we have something object like 1 nanometer and it has some properties, chemical, magnetic, optical, eh, whenever you switch to 2 nanometer, it will not show
It will not show.
as nanometer particle will show. It will drastically change all the properties with the just switch of 1 nanometer to 2 nanometer particle size. So one kind of particle can be responsible for 1 to 100 nanometer size properties. Here are some of the sizes I have mentioned. Eh, I have already told why this scale is different, because of two major contributors. One is called surface to volume ratio, mean larger, many or almost all atoms are on the surface. No atom is inside in the body. And second concept is a quantum confinement effect. Here is a brief slide. Who are interested, they can have a click. A large surface to volume ratio means higher number of the atoms will be on the surface and only few exist inside. Similarly, we have quantum confinement effect. Most of the physics students are already familiar with the quantum size effect. And quantum size effect origin belongs to Cronin-Penny model. Mean we have some free space or zero potential for a particle to exist inside this, and the particle will move freely according to de Broglie wavelength. Uh, in the nano, we have enhanced optical electronic property, size dependent excitonic properties. We have quantum confinement, dark effect, fabrication of nanomaterial. Nano, I am just touching briefly and coming up to the main part, synthesizing of nanoparticles. We have fabrication material. We can synthesize nanomaterials by two ways: top-down approach and bottom-up approach. In the figure, you can see if we start with a bigger material, then slicing down it to some nanomaterial, or similarly, we can build atom by atom a cluster, then we can have nanoparticles. In this era, we have a new technology called green synthesis method to synthesize nanomaterials. Earlier, we used to synthesize nanomaterial by chemical route. For example, ZNO, titania, SNO2, they are synthesized by chemical method. And the size and shape is controlled by capping agent. Capping agent is like a chemical agent. Whenever our particle is synthesized, a layer of chemical which is used to control the size is present on that particle, and because of this particle will show some toxic effect. So in green method, we use some plants extract to synthesize nanoparticles to control the shape and size of the particles. To control these type of particles, we have first method in the bottom-up method, hydrothermal synthesis. For hydrothermal synthesis, we need an autoclave. Here in the pictorial diagram, you can easily say, oh, what is autoclave? Autoclave is like a pressure cooker. You can easily synthesize nanoparticles by controlling pressure and temperature. Now, to synthesize nanoparticles, first we need chemicals, and second, stabilizing agent. Means the surface of the nanoparticle must be stabilized. Eh, In the green method, here in the pictorial, these are some of the fruits, juices, plant waste, vegetable and leaves, from which we can easily get some extract. After getting the extract, we mix with them some chemicals. We set up some pH, some reaction condition like temperature, stirring rate, and After mixing, we pour them into the our wax hydrothermal autoclave. After certain period of reaction, within 1 or 2 hours, we get the nanoparticles. This is one of the earlier work our team has carried out. We have extracted phytochemicals. Phytochemicals means capping and stabilizing agents from these plants. Eh, Now, how will you ensure what you obtain from plant? So we will have to take here GCMS. So first of all, we have to go GCMS. In GCMS, we can easily identify what the papaya extract mainly comprises of. Is it something having like reducing agent, capping agent, or something else? So while synthesizing green nanoparticles, you first have to take care of the GCMS. These are some of the phytochemicals identified in the GCMS. After GCMS identify number of stabilizing, capping, flavonoid, antioxidants, then you can start the synthesis process like a typical method I have shown here, a simple recipe of synthesizing nanoparticles. This is the pictorial view how we can synthesize the nanoparticle. We start with the chemicals, then we start pouring some extract. After addition, we give them hydrothermal treatment and triangle signing, we get the papaya. Now, what is the secret of synthesis? How much extract you need, how much time you need to give reaction. Sometimes depend on self-understanding, sometimes paper needs, reviewers command demand. So in this way, the peak shows a critical reaction time and critical concentration of the precursor. When you achieve this concentration, this peak will happen. Whenever this peak will happen, the nanoparticle will start forming. Before this, the nanoparticle will dissolve. After that, the particle will grow. So this is the basic theory behind the synthesis of nanoparticle. So you need to be a critical limiting supersaturation. Okay. Now, most of time we are unsure that our nanoparticles are formed or not formed. So you can take in situ U visible spectroscopy technique. I have set in this graph pH 6, 7, 8, 9, and 10. And you can easily see in the pH of 9, we have a very crisp and clear peak. So this peak shows that we have achieved the optimum reaction conditions like pH 9 is the best formation for the particle of choice of synthesis. So you have to optimize this. Now here you can see we have a very clear peak, absorption peak. These are some of the multispectral synthesized by Z nanoparticles which are mediated by Cassia papaya. So another secret of synthesis is what is the reaction time for the synthesizing of nanomaterials. You have to stir for 20 minutes, 10 minutes, 40 minutes, 60 minutes, or 100 minutes. A very difficult task. Most of the students or the researcher let it be for 2 hours, 3 hours, 4 hours, or whole night. But with the help of UV visible spectroscopy, you can easily monitor these. You can see from A to A, G different peak size. From figure A, no peak is formed. From figure B, you can easily say after 10 minutes, the reaction is complete. After that, in figure 20 minutes, in the C, 20 minutes, the same peak will there. In D, after 30 minutes, the peak going to be settled down. Settled down means the particle become heavier in the solution and they are settling down, so peak is not forming properly. So according to this, we can stop our reaction within 20 minutes. 20 minutes are enough to complete this reaction. So here a pictorial view once again. We can have another capping agent, another extract. Here we are using peel extract to synthesize nanoparticles. So this is once again a typical protocol for synthesizing nanoparticles. This is now we have some chemical synthesis method also. We have used here polyethylene glycol for synthesizing the nanoparticle. Actually, we have to modify the chemical methods by green method. To compare that, we have also synthesized the nanoparticle by chemical routes. So this is one of the pictorial view. Same hydrothermal method, but we have not used here green extract. We have used PEG, and we have once again able to get multi-structure. So by using a green method, this happen. Why? This happens when we have used phytochemicals. Now, why hydrothermal? Hydrothermal is a very good technique to control over shape. You can see here the different shape. We have a here you can see dumbbell-like shape, pyramidal-like shape, screw-like shape. So hydrothermal is one of the best method to synthesize a unique shape. But this happens only when you have something like controlling agent, stabilizing agent. In sea limita we have different shapes. In orange field we have different shapes. In piper beetle we have different shapes. So this shows the effect of extract phytochemicals on synthesizing the nanoparticles. Chemical precipitation technique also involves the use of chemicals. This is one of the another example, piper beetle. We have used piper beetle leaves to synthesize cobalt particles, a different phase of cobalt 303O4. This is a typical recipe to synthesize nanoparticles. Once you have to identify the chemicals, phytochemicals, then you let some concentration of phytochemicals to the main chemical solvent after synthesizing. This is the one of the, I think, chemical precipitation method. This method is more time efficient, more easy to perform in a new lab wherever one has set. Uh, this is a typical, and these are the some of the particles which we have obtained using piper beetle. Once again, the shape is beautifully controlled. You can see the size range of particle is 30 nanometer range. This is the pictorial view. Once again, we have synthesized this using the chemical precipitation technique. This is the one of the typical recipes to synthesize these nanoparticles. Uh, Similarly, we have nickel oxide particles by using piper beetle leaf extract. We have here some hexagonal, pentagonal, another unique shape. And once again, we have size in the range of 30 nanometers. We have another technique like soul gel method. In the soul gel method, we have another like titania salt. Once again, we use titania. There are a number of steps we use to modify its shape, and this is a chemical reaction happening inside. These are the structure we obtain by C Lyman TiO2 particle. These are some of the basic recipes to synthesize the nanoparticles. Nanoparticle synthesis is a complex and challenging process, but it's essential for the development of new and innovative material with a wide range of applications. Everybody synthesizing nanoparticle, exploring the properties of nanoparticle. They all will lead to a particle having a green layer on it. Eh, That can be used in medicine, that can be used on clothes, that can be used in toothpaste, skincare products, even in eating products. But we have to stabilize its surface by some green method. In conclusion, we can use chemical methods. However, they are toxic. They are not suitable for all human touch surfaces. Eh, to replace it, we can have some green methods, and we are in the era of a green synthesis method, which will take, I think, 5 to 10 years to come up in the market for a layman person. If you have any query regarding synthesis methods, if any kind of reaction you want to optimize or any kind of size you want to optimize, you have to optimize the reaction condition. UV visual spectroscopy is one of the finest tools to synthesize nanomaterials. Thank you. If you have something to ask in this type in this slide, you can most welcome, or you want to understand the synthesis or any tips, we can have discussion.